Hello everyone. So this video will focus on the next week's storm threat for Tuesday into Wednesday, which brings us into Christmas Eve. So we're going to look at the European model, and just to save time I will not go through the other models, but I will talk about the differences in the modeling, and there are quite a few. But the one thing that all the models have in common, which is very rare that a week out they have this in common, is they all have a storm. So there's going to be a pretty big storm next week. We know that by now. So looking at the European model, I'm going to skip this weekend storm because it's just not interesting anymore. It's not even that potent, so if we get anything from it, it'll be very light. If you look here, see, this is the disturbance that brings us light precipitation this weekend. And briefly, just to go over the maps again, this is 500 millibar vorticity. This talks about or conveys the pieces of energy that are throughout the atmosphere. So wherever you have a piece of energy, you usually have an area of low pressure associated with it on your high and low map. So these are the two maps I will refer to in the video. As we go along here, this is Saturday, tomorrow night, and here is Sunday night, and this is the piece of energy that we're concerned about, this large trough here. And it's associated with this area of low pressure here, which is not strong yet, but it's going to intensify. Now, this setup next week is really conducive for a big snowstorm because you have this area of high pressure out over the Pacific that causes the jet stream to dip southward and come back up. And the reason the I-95 corridor, the Mid-Atlantic and most of New England, escaped this without any snow is because this high is not far enough east so that the dip in the jet stream is also further east, and then that would come up the coast. It's going to come up to the northwest, but west of New England and the Mid-Atlantic. So I will talk more about that when we get to it. I have a threat map and everything. But going back to the vorticity map, here's the piece of energy that creates the storm. And this is Monday evening, so we went ahead one frame. You can notice that you're getting a bit of a darker red up here, so it is strengthening this piece of energy. Here is your storm. And if you notice, you kind of have more energy concentrated to the south, so these two pieces are not yet really consolidated. So you have two separate areas of low pressure. And another key to where this storm goes is, where does that energy become concentrated? If that energy becomes concentrated further to the south, then this storm will track further east. And then the I-95 corridor might have to worry about some snow. However, what all the models are showing is that for a period of time there might be energy concentrated down here, but it's going to come back up north, and your main storm is going to be at the northern end of this shortwave. And that's why the storm is going to track further to the north and west, and that's why the Midwest is going to be getting the snow from this storm. So if we move along, here it is. This is Tuesday evening. Here's your trough, and you can see it looks like it's concentrated in the south, and even this area of low pressure here, it's not too far north yet. It's further south than the other models than the American model is showing. So that's that. And then, however, in the next run, you're going to see this energy come back to the north and west. So let's do that. See that? Here it's in the southeastern side of the shortwave. There it's in the northwestern side of the shortwave. So that's where that energy concentrates. This is Wednesday evening, so this is Christmas Eve. And your low is over the Great Lakes. Look at all the circles around it. Look at how strong. This really strengthens as it comes to the north and west. And that's another key in how much snow people are going to get in the Midwest. Alright? Also, again, notice how you have circles around it. That means that the low is closing off, and that happens as a result of intense strengthening. And that'll also play a role because a closed low generates cold air, and it can produce very heavy precipitation on its northern and western sides. So people that are close to the proximity of the closed low on the western side will be getting a lot more snow than areas that are further away. So I think there's going to be a very narrow band of up to a foot across the Midwest, depending on where this low goes. Okay, now differences in modeling. The American model, if we come back here, notice how the European does bring the energy further to the south. The American model has it further to the north. And it stays that way. So there's not really a second storm in the beginning. It all comes up to the north, and this low doesn't come to the south. It stays in the north, and it tracks further to the west. So that would push the snow threat further west across Wisconsin. I believe that's Minnesota. I'm not really good with states. And northwestern Michigan. With the European, it's more towards a little further east, not by much. The Canadian model, like the European, does bring energy further to the south, and actually has the storm intensifying southward, believe it or not. But again, it eventually comes back up north, and it takes a track west of the I-95. However, the Canadian model is the furthest east. It takes the low right through western Pennsylvania, right through western New York, and then back up into southeastern Canada. So the European is the middle ground, the Canadian model is furthest east, and the American model is furthest to the west. Alright, so what does this mean? And I'm going to bring up my threat map now. Okay. So here is the graphic that I created. So I've been talking a lot about the possibility of a snowstorm in the Midwest here. I want to talk about the heavy rain and wind along the coast. Now, when a low tracks to the north and west of the I-95, I want you to think about the way the winds rotate around an area of low pressure. They rotate counterclockwise. So if the low passes to the north and west, you have a southwest flow, meaning winds are coming out of the southwest. And what that does is it brings in warmer air from the Gulf down here, Gulf of Mexico. And so because this low tracks to our north and west, we're going to warm up as this thing passes by, and we are going to get heavy rain rather than snow. And I think that we have a chance of getting some stronger thunderstorms, especially across the mid-Atlantic, and maybe extending up into the lower Hudson Valley, southern Connecticut, perhaps. It all depends on how much instability there is in the atmosphere. Now, I don't think there will be enough instability for severe weather that far north across the lower Hudson Valley and southern New England. I think the mid-Atlantic and going down into the southeast will have more instability and a better chance at severe thunderstorms on Wednesday. But I still think that there's going to be enough energy in the lower atmosphere in terms of low-level winds that we could get some stronger thunderstorms with gusty winds across southern New England here, southern Connecticut, lower Hudson Valley, New Jersey, and to the Delmarva. So I'm worried about potential heavy rain, gusty winds there. And then further on north, what I'm concerned about is this trough is going to move through like that. So here's your trough that moves through. Notice how it's negatively tilted. So it's tilted to the left. So what that means is it's going to be drawing in moisture from the ocean. So as this trough moves through, and most of the models are showing this, you're going to have a band of really heavy rain advancing north and eastward up into northern New England. And I'm afraid that a lot of rain is going to fall in a very short time, and that we're going to get some flooding issues on Wednesday into Wednesday night as this trough swings on through. I don't know if it'll be warm enough. We might get some thunderstorms up into northern New England as well. I'm not thinking severe. I'm thinking thunderstorms with heavy rain and possible gusty winds. Right? So, oops, I don't know why I clicked into Facebook. So, moving along, going back to our threat map, there's a couple of other things that you need to pay attention to in terms of who's getting the most snow. So, I've highlighted my snowstorm threat to be, again, west of the New England I-95 corridor, mainly across the northern portions of the Midwest. So, the eastern extent that I've put this is as far east as the models go with a possible track of the low. So the Canadian model kind of brings the low across central PA and into western New York. And that's as far east as I think it's going to come. I don't think it's going to come further east than that. So I think that this is your main threat area here. So most of Ohio, Indiana, Michigan, Wisconsin back in here. Maybe eastern Wisconsin. The map didn't go that far, so I couldn't include Wisconsin in the threat area. But because the American model goes further west, I think we can throw eastern Wisconsin on the threat area. Minnesota here. And then you have Illinois. Chicago, you are in the threat area for a big snowstorm. So is Detroit. But what I think here, I think areas that are on the northern periphery have the better chance of getting a foot of snow. And the reason for that is the amount of snow that the portions of the Midwest get from this depends on how quickly this strengthens. Because as this strengthens, your snows are going to start to pick up on the western end. So if this strengthens quickly enough, then southern areas of the threat might also get heavier snow. But if it doesn't strengthen until it gets all the way up into the Great Lakes, then your main areas getting a foot or more of snow are going to be further north. So that's why I think northern Michigan, northwestern Michigan, northeastern Minnesota have a better chance of getting heavier snow amounts. And then down in here, somewhat less. But I still think there's a potential for up to 6 inches down in the southern areas here. Alright, so that's the basic idea. And, of course, this rain and snow line is going to be very big. Because depending on where the low goes, that's where the break-off between rain and snow is going to be. So some areas that are in this bubble right now might actually get rain rather than snow if the low tracks further west. Or this might have to be extended further east if the low comes further east. So it's a big guessing game right now with this storm. But what I can tell you is that we have a big storm on tap for next week. So stay tuned to the weather updates and make sure you adjust your travel plans accordingly. So again, down in here into the central portion of the Mid-Atlantic here, I'm going with Tuesday night into Wednesday. Further north, Wednesday into Wednesday night is where the timing of this will be. Now, after that, in my previous video, I had talked about how I was excited because after this trough moves through, on the backside of a trough, you always have a deliverance of colder air. And I was excited that perhaps after this storm moves through, we get a shot of cold air, which we will. And that could set up the I-95 corridor where I'm located for a snowstorm. However, there's a problem. There's always a problem when it comes to getting snow along the I-95 corridor. It's really annoying. And the problem is on this weather map here. So, when you have an area of low pressure, winds rotate counterclockwise. So after a low moves through, this low here, you have the winds rotating counterclockwise. That delivers Arctic air to the northeast. And there's a problem, though. And the problem is this high right here, which all the models are showing will develop over the southeast. Around a high, you have winds that are rotating, rather than counterclockwise, you have rotating clockwise winds. So, because this high is over the southeast here, it's going to be rotating warmer ocean air up into the northeast after the storm moves through. So we will get cold after the Christmas Day storm. However, we're going to warm up again by the weekend. This is Thursday night. Because you have this high here, you have another system coming through. And because you have this high here, where's this system going to go? It's going to go like that. It's going to pass to the north and west again of the I-95. So I'm thinking Friday into next weekend, we're going to get another bit of another storm here, another possible snow threat for the Midwest, and another threat of heavy rain for the Northeast. It's like a double whammy here with this exact same type of storm. However, I just want to go to the extended run here. So this is what we were just looking at. It's not on this map, but this is high pressure here. This is the second storm for next weekend. That moves to the north and east and passes through. See, it takes a very similar track to the Christmas Day storm. However, behind this, you have Arctic air coming on in. So, if we go ahead, that moves up. Your Arctic air mass comes on in, and it's coming pretty far south. No longer have high pressure down here. So now, by New Year's week, I think we are set up for a possible snowstorm along the I-95 and New England. what we have to watch for, though, is we need energy to come onto the west coast over here, and it needs to track along the jet stream here. The dip will be somewhat like this, because you have high pressure all the way up into the northwest here, so the dip in the jet stream is going to be pretty favorable for something to come down, form a storm in the Gulf, and then come up the coast. So I'm very interested to see what the models do, but this is as far as the European model goes, and right now it's not showing a storm. So as the runs come in, we'll keep updating that. But I'm thinking by New Year's we should be set up for a possible snowstorm, which is what we all want, or at least what I want. Okay, so that is the video. Thank you for watching. We'll keep updating. I'll probably post another one tomorrow if the models are changing, which they will. So thank you for watching. Oh, and another thing. I always get complaints that I never show my face in the video. So really quickly, here's my face. There, you saw it. Hopefully. I don't know how good of a shot that was. You saw it. There you go. There's my face. Alright, thank you for watching.